Here we are in section 4.2 exercises part C. It says graph the following lines, so we need to make sure we have 2 points and label 3 points. Oh, we need to find a third. Okay, let's pick a point to start with. Or pick a number to stick in. We can pick in anything we want. Let's stick 0 for x. I think zeros make it a little bit easier. If we stick 0 in for x, we get 4 times 0 is 0 plus 2y equals 10. Divide both sides by 2 and we get y equals 5. So the point 0, 1, 2, 3, 4, 5 is about up here. Good. Let's try a second point. Well, that worked pretty well for the x's. Let's stick it in for the y's. Stick a 0 up here for y. Let's see if it works pretty well. 4x plus 2y, but that's 0 plus 2 times 0 equals 10. So divide by 4 and we get x equals 10 fourths. 10 fourths, which reduces down to 5 halves, or a decimal of about 2.5. So go over about 2.5, 0, and we're right there. So we can tell where our line's going to be. It's going to be right down there. Okay, but we still need a third one because it says label 3 points. So let's pick just some random, 7. And let's see where we are. Sticking 7 in, we get 28 plus 2y equals 10. Subtract 28 from both sides and we get 2y equals negative 18. Divide by 2 and we get y equals a negative 9. So 7 goes with negative 9. So we're over 7 and down negative 9. We'll have to fall right on that line. Yes, indeed we do. So the line should look like, there we go, close enough. Almost hit that one. There we go. That looks a little better. Let's check our answer, see if we got the line. Yeah, that's what it looks like right there. And they picked the same 2 points we did, but a third point. And there are billions of points to choose from, so your points don't need to necessarily match up exactly with the back of the book. Number 12, y equals negative 2x minus 7. Well, my favorite one to try is that 0 to begin with. Stick 0 in for x, and I get y equals negative 2 times 0 is 0 minus 7. Y equals a negative 7. So we start down here at 0, negative 7. That's our y-intercept. For a second point, we could stick in 0 for y, and then we could add and subtract things over, but since y is by itself already and solved for, let's just pick some new numbers for x. So I'm going to pick 2 for x. Let's see what we get. If we stick it in, we get y equals negative 2 times 2 is y equals a negative 4 minus 7. Negative 4 minus 7 is negative 11. So we get positive 2, negative 11. So 1, 2, but then down 11. So we're clear down here. So we can tell where the line's going to go. And now let's just get that third point. So if we stick in, let's try sticking in like negative 2 and see what it looks like. Y equals negative 2 times negative 2 would be a positive 4. Y equals a positive 4 minus 7. That's a negative 3. So y equals a negative 3. So back this way 2 and down 3. Oh yeah, you can kind of see that we're going to be on the same line. So let's draw this if we can. Right up here. Good. And right down there. Rough drawing there. Let's check the answer. Oh, what a computer can do much better. And you'll see it goes right down through there. And they used completely different ones than what we did. Well, they had 0, negative 7, but they had a couple of different ones there. All right, let's look at the next one. Number 13, y equals 3 halves x. I like that that y-intercept, so let's put 0 in for x and see what we get. Y equals, it's almost too easy to even stick in. Y equals 3 halves times 0 is 0. So we go right through the origin in this case. The intercept is right on the origin. Let's try another one. Stick in Ooh, we have a fraction to worry about. Let's stick in like something that'll cancel there, like a 2. There we go. So y equals 3 halves times 2. 3 halves times 2, that'll just cancel and leave a 3. So 2, 3 goes up right there. Good. Let's do green for the third point. And what should we do for that third point? Something else that'll cancel with 2. How about like a 6? That'll cancel there. Y equals 3 halves times 6. So you can do 3 times 6 is 18, divided by 2 is 9. Or you can, 6 divided by 2 is 3, and 3 times 3 is 9. So you go out 6 and up like 9. And it should be on that same general pattern right there. So let's see if we can connect the dots. There we go. And check our answer. Number 13. Yeah, it goes right through, hits the origin. They look like they're a little bit off right there with the printing. But yeah, that's what it looks like. Oh, look, they did one of the same problems we did, one of the same things. And then, nope, we didn't match up on the third problem, but there are billions of them to choose from. Okay, the next one, number 14. X equals 5. Well, here we can't stick in x is 0. That won't make any sense. Let's put a 0 in for y, and x equals 5. Or if we tried y equals 7, what does x equal? 5. So really we just have to label 3 points where the x is 5. Let's do like a -1. Yeah, the x is always 5. That's what that equation is telling us. And so if we graph this, we have 5, 0 right there. And then the red one, 5, 7 is right up here. And then the third one, 5, -1 would be right there. And we see, yep, we've got a line straight up and down. There we go, close to that. Let's check our answer. And number 14. Yeah, they got a little creative here. They picked 5, 2, 5, 0, and then 5, -3.4. And really anything with the x value of 5 will work. And there's their x equals 5 line. Number 15. Y equals -3/7 x minus 2. All right. Stick in 0 for x and see what we get. This is a nice one. -3/7 times 0. We get y equals 0 minus 2. Oh, -2. And you see this pattern when y is by itself, sticking in 0 starts to give us that number on the end because it multiplies anything there by 0. So 0, -2, there we go. The second point, let's try one that might get rid of those fractions for us, or we could get fractions in our answer, but not so bad if we do, but it's a little bit easier if we are able to cancel it. Pick any number in the world, let's pick a 7. That'll help us. Y equals, we got -3/7 times 7 minus 2. So times the 7, canceled. -3 minus 2 is a -5. So we have 7 over, and what is that? Down 5. So we're about right there. Okay, so our line is going to come up like this. Let's go ahead and pick another one for our third point. How about -7? That'll cancel out the negative and the fraction. So we're going to get y equals a -3/7 times a -7 minus 2. And you can stick that in your calculator if you want to, but the negatives will cancel. And the 7s will cancel. And we'll get 3 minus 2 gets a 1. Y equals 1. So you go back -7 and up 1, and you'll see we're right along that line. Let's see if we can draw it. And it comes in like this. There we go. Let's double check that answer, number 15. Yeah, it goes right down there. You'll notice they did the same points we did. Well, it was kind of a smart thing to try to get rid of that fraction and get nice round numbers there. Okay, next one. Number 16. 7x minus 5y equals 12. Well, let's stick in 0 for x, see what we get. If we get 0 times 7, that's 0, minus 5y equals 12. Divide by a -5, we get y equals -12/5. Oh, that was a fraction, darn. But we know that if you plug that in the calculator, that's about negative 2.4. So the first one is 0, and there's about negative 2, a little bit further than that. And that's okay. It's just kind of a rough sketch of where it is. Let's try the next one. This one we could put 0 in for y and do it almost as quick. Put 0 in for y right there. We get 7x minus 0 equals 12. So divide by 7, we get x equals 12 sevenths. Ooh, 12 sevenths. So this number, if you stick it in, is going to be about 1.71. So let's come over here, just under 2, and there's our next point. That might be a little bit off, but it's pretty close. And we've got to get that third point. So we know where the line is going now, and this is just pro bono. So let's stick in something like 3. 3 for x, we can stick in anything we want. We get 21, that's 7 times 3, minus 5y equals 12. Subtract 21, and we get minus 5y equals a negative 9, and then negative 5, we divide it off. Y equals positive 9 fifths, because a negative divided by a negative gives you a positive. So 9 fifths. So when we are out 3, we're up about 1.8. So we go out about 3 and up 1.8. And yeah, we're right on that line. Let's see what that guy looks like when we graph it. Let's see if we can come down right there. Pretty good. There we go. Let's check our answer. Number 16. And yeah, that's what it looks like. Ooh, they did get the intercepts. Oh, they found a nice round even point with no fractions. Good for them. We were able to find our point. It was just a little bit off of where they went, but it's good. Number 17, y equals negative 3. Now if we notice this one, this is pretty nice because there are no x. That just means we need to make up 3 points where the y is a negative 3. So we can be 0, negative 3, which is what? Right down here. And make up another one. If x is 5, we're negative 3. So that's over 5 at the same distance down. And then the last one, I don't know, negative 7.2 and negative 3. Yeah. So negative 7.2, I don't know where it is, but it's at negative 3 right down there for the y. And that gives us a horizontal line. It's good to note right there. Horizontal look like y equals something, and vertical lines look like x equals something. And there we have number 17 with the straight across at negative 3. And the last one, number 18. 5x plus 2y equals 6. Well, what do we have here? If we stick in x is 0, that's my favorite one. Stick in 0 for x, and we get 2y equals 6. Can we solve that? 2y equals 6? Yeah, divide by 2, we get y equals 3. There we go, 0, 3, right about up there. How about the next one? Let's try the other intercept. Stick a 0 in for y and see what x equals. So stick 0 up there, and we get 5x plus 0 equals 6. Divide by 5 on both sides, and we get x equals 6 fifths. Alrighty, there we go. So 6 fifths 0, that's just in the calculator, that'd be 1.2. So it's out about there. So we know where the line is going to be, so we need to find just one other point to follow the instructions. Let's put in x as 4, see what happens. If we stick x in as 4, 5 times 4 is 20, plus 2y equals 6. Subtract 20 from both sides, and we get 2y equals negative 14. Divide by 2, and we get y equals a negative 7. Oh, yeah. So 4, negative 7. If we go over 4 and down 7, oh my word, yep. And so it should fall right in line with those other two. And let's see if we can connect the dots here. That's a little bit crooked there. But let's see, check our answer. And then number 18, really kind of a steep slanted downward type line right there. Good.